all from worksheet number 2. I'm going to do the evens with you. All right, number 2. I'm going to have 4x plus 2 over root x plus 1 equals 3 root x. I know I have a radical in the denominator, but I'm not that concerned because when we have one ratio equaling another, what are we allowed to do? Cross multiply, and that's what we want to do. We want to cross multiply here. So when I cross multiply, I'm going to get 3 root x times the quantity of root x plus 1 is equal to 4x plus 2. I have to distribute in that 3 root x. So when I distribute this in, I'm going to get 3, but what's root x times root x? X plus 3 root x equals 4x plus 2. Do we all agree this is a radical equation? Right? When there's a radical equation, we want to isolate the radicals. So I'm subtracting the 3x here. So we're going to have 3 root x is equal to x plus 2. I'm then going to divide by 3. And I'm going to have root x is equal to x plus 2 over 3. To undo that square root, what are we going to do? Square it. But when I square that numerator, I have to FOIL that out. And when you FOIL it out, you're going to get x squared plus 4x plus 4. And then our denominator is 9. I'm going to cross multiply again. So I'm going to have now 9x is equal to x squared plus 4x plus 4. We're going to have to factor, so I'm subtracting that 9x. So we are x squared minus 5x plus 4 equals 0. When we factor, we get x minus 4, x minus 1 equals 0, and x will equal 4, x will equal 1. I believe they both work. Okay, so that's number 2. Let's look at number 4. This is 4 from the worksheet. All right, do you agree we're solving for x here? Kai, what's wrong?
Can you go over like checking the 1?
Sure.
Just to go over like the rules of like 1 under a radical.
So when you check, you go back to the original. So this is 4 times 1 plus 2 over the root of 1 plus 1 equals 3 root 1 over 1. But what's the square root of 1? 1, right? Square root of 1 is 1. So this is going to be 4 plus 2 over 1 plus 1 equals 3 over 1. So 4 plus 2 is 6 over 2 equals 3 over 1, and 3 is equal to 3. Good? Hi, did you say the square root of 1 was not 1? Hi. Okay, For this next one, we said this was number 4 from the worksheet. We're solving for x. I'm going to actually leave it an exponential. I need that exponent to be 1. Because I need that exponent to be 1, what am I going to do? I'm going to raise it to what power? Tejas? Negative 4 over 3. And now on the right side, what do you think I'm going to change that 8 to? Kai? Yep, 2 to the 3rd power raised to the negative 4/3 power. Do I need to do plus or minus here? No, we only do plus or minus when what? The denominator's even. So we do not need to do plus or minus here. So we end up with 2 raised to the negative 4th power, which is going to give us 1 over 16. Okay, next one. Okay, so this is going to be a bit of a pain. So this is z to the 1/4 plus 2 over z to the 1/4 equals 3. It is an equation, and it is an equation with a denominator. I don't like dealing with equations that have denominators or equations with fractions. So my instinct is anytime I have that, I want to eliminate the denominator. How am I going to eliminate the denominator? Multiply everything by z to the 1/4. So when I multiply everything by z to the 1/4, so I'm not rationalizing, guys. I'm just multiplying everything by z to the 1/4. So z to the 1/4 times z to the 1/4, do we all agree that's z to the 2/4? And then the second term, what happens with the z's? They cancel. So this is plus 2 equals 3z to the 1/4. All right. I hope you recognize something. I don't know if you do, but I hope you recognize something. This is z to the 2/4. I'm leaving it like that for now. Minus 3z to the 1/4 plus 2. Anybody recognize anything here? Danny? You can factor. Isn't this exponent double this one, or this one is half of this one, right? So because of that, we can factor. If you want to use substitution, you absolutely can use substitution. So we're going to say let x equals z to the 1/4. So what we're going to have is x squared minus 3x plus 2 equals 0. Can we factor this? Absolutely. X minus 2, x minus 1. So we get x is equal to 2 and x is equal to 1. Yes? Okay, but these are not our answers, right? What do we have to do now? We substituted, now substitute back. So x doesn't equal 2. What equals 2? Z to the 1/4 is equal to 2. And z to the 1/4 is equal to 1. We need to solve for z. If we're going to solve for z, what do I have to do? Raise it to the 4th power. So we're going to get z is equal to 16 is one answer. And then on this side, we raise it to the 4th power. What's 1 to the 4th power, Kai? Good. So z also equals 1. Both answers work. What was your question, Philip?
I was going to ask, after we kind of back to the trinomial, if we would consider that the prime answer and then kind of go to the...
Okay. I'm going to do an odd one. Actually, no, I'm not. I'm good. All right, 8. Okay, so for number 8, I'm going step by step here. So this is, oh, sorry, this is not 5 squared. This is just 5. So here I'm going to have the root of x plus 25 minus the root of x raised to the half equals 5. Do we agree? Okay, so now I'm going to go step by step here. I have it raised to the half power. To cancel that out, what should I do? Square it. Do I need plus or minus? No, we don't need plus or minus here. So now this is the root of x plus 25 minus the root of x equals 25. Okay, so now we generally want to isolate the radical, but in this scenario we can't isolate the radicals because there's 2 different radicals. I can't combine them. But because this number is an integer on this side, I'm going to recommend we move one of these radicals to the other side. So I'm going to move the minus root x to the other side, and I'm going to get root of x plus 25 equals 25 plus root x. What do you think I'm going to do now? What am I going to do now, Tori? We're going to square both sides. When I square the left side, it cancels the radical, so we're just x plus 25. What do I have to do on the right side? I have to FOIL. You cannot distribute that exponent. So 25 times 25 is 625. 25 times root x is 25 root x. Root x times 25 is 25 root x. And root x times root x is x. I'm going to combine my like terms, so I have x plus 25 equals 625 plus 50x plus, oh, not 50x, 50 root x plus x. Have we gotten it down to one radical? Yes, we've gotten it down to one radical, which means I need to isolate that radical. So I'm going to subtract x on both sides, and when I subtract x on both sides, they both cancel. Then I'm going to subtract 625 on both sides, and I'm going to get negative 600 equals 50 root x. I'm going to stop here and say there should be there should be like sort of a hazard light going off in our heads. Does anybody know why I'm saying this? Even if you took it a step further and divided by 50, there should still be some kind of like this isn't going to work type thing. Tori? Yeah, there is no way if we take the square root of something, it will ever come out to be negative. There's no way, unless if we have even if we have a negative under here, it comes out to be imaginary, right? So this cannot work. So at this point, what do we realize? This is a no solution. How am I doing on time? Okay, let's try to do one more. I want us, this is number 12. I want us to solve for C. T equals 3x over the root of m minus c squared. All right, I'm going to cross multiply. So I'm going to get t root m minus c squared equals 3x. So all I did was cross multiply. I need to isolate the radical, so I'm dividing by t. So now I'm going to have the root of m minus c squared equals 3x over t. Now that I've isolated the radical, now what I want to do is I want to square both sides. When I square both sides, I'm going to get m minus c squared equals 9x squared over t squared. I'm now going to subtract that m on both sides. So now I have negative c squared equals 9x squared over t squared minus m. What do you think I'm going to tell you you need to do on the right side to simplify that? Common denominator. You need a common denominator of t squared. So we have negative c squared equals 9x squared over t squared minus mt squared over t squared. I multiplied top and bottom by t squared to make a common denominator. So now I have negative c squared equals 9x squared minus mt squared all over t squared. We're now going to divide by negative 1. So we're going to have c squared equals, we have the negation of 9x squared minus mt squared all over t squared. You could distribute in that negative, so c squared equals negative 9x squared plus mt squared all over t squared. Now, lastly, we're solving for c. To undo a square, we take the square root, and c will equal plus or minus the root of mt squared minus 9x squared all over t squared. Can we leave a fraction underneath a radical? No. So now we split this. So c will equal plus or minus the root of mt squared minus 9x squared all over the square root of t squared. But what's the square root of t squared? T. So c is equal to plus or minus the root of mt squared minus 9x squared over t. And that's your answer for C. All right, we are done. Your homework is going to be the odd problem. So I did the even problems. Your homework is going to be the odds.